My dear students, in this video I am going to find probability density function from the distribution function. The distribution function capital F of x is given. From that distribution function we have to find out the probability density function. That's our task. Probability density function from distribution function. That's our topic. We know that the probability density function is f of x. We know that the probability density function f of x of a continuous random variable x is to be derived from distribution function f of x. That's our task. We have to find this probability density function f of x from the distribution function capital F of x. We know the distribution function capital F of x is probability of x less than or equal to x, that is equal to integral minus infinity to x density function f of x into dx. See, here is an idea. If you integrate the density function, you will get the distribution function. If you integrate the density function, we will get the distribution function. From this, to find out the distribution density function from the distribution function, reverse. If the density function is given, probability density function f of x is given, it should be integrated from minus infinity to x, you will get the distribution function capital F of x. Now in this case, capital F of x is given, we have to find out the density function small f of x. See, of integrating this density function, we will get capital F of x. Therefore, to get the density function small f of x from the distribution function capital F of x, we have to reciprocal action of integration, that is derivative of the function capital F of x gives you the probability density function. That is, the probability density function small f of x of a continuous random variable x is nothing but the derivative of distribution function, that is d by dx of distribution function capital F of x is equal to is f dash of x. That is nothing. This gives you the, what is that? Distribution density function f of x. Therefore, to get the density function f of x, we have to differentiate the probability distribution function. If you differentiate this distribution function, we will get density function. If you integrate the density function, we will get the distribution function. These two are opposite actions. If you integrate density function, we will get distribution function. If you differentiate distribution function, we will get density function. That's all. Okay. Now we will solve one problem to find the probability density function if the distribution function is given. So you consider this problem in the exercise 11.3. This is problem number 6 in the exercise 11.3. Capital F of x, that is distribution function, is given by 0 for minus infinity less than x less than 0. In this interval, the distribution function is 0. And from 0 less than or equal to x less than 1, in this interval 0 to 1, the distribution function capital F of x is of into x square plus x. And otherwise from 1 less than or equal to x less than infinity, the distribution function capital F of x is 1. Is given. So, from interval minus infinity to 0, capital F of x is 0. From the interval 0 to 1, capital F of x is half into x square plus x. And from the interval 1 to infinity, the function is distribution function is capital F of x is 1. From this data, you have to find out the probability density function. First case is find the find. First question is find the probability density function. Find the probability density function 1. And second subdivision is probability of 0.3 less than or equal to x less than or equal to 6. You find these two ends. Two subdivisions in this problem. Capital F of x is given. We know that the probability density function, probability density function small f of x is, if capital F of x is given, small f of x, you know, d by dx of the derivative of the distributive function. You know what? To find the density function, we have to differentiate the distribution function with respect to x. So first case, for the interval minus infinity to 0, f dash of x, in the interval minus infinity less than x less than 0, in the interval minus infinity less than x less than 0, d by dx of, in this interval, d by dx of f of x, in this case, d by dx in this interval is 0, therefore this is 0. Because in the interval function is 0, the derivative is also 0. So f of x is 0. Similarly, in the second interval, 0 less than or equal to x less than 1, f of x we want, that is d by dx of f of x, that is equal to d by dx of, in this interval f of x is half into x square plus x. So on differentiating, you will get d by half, you can take the constant of out of the derivative symbol, half into d by dx of x square. You know the derivative of x square is 2x plus derivative d by dx of x is 1. Differentiation of x square is 2x and the differentiation of x with respect to x is 1. Therefore, if you multiply this off with this in each term in the bracket, you will get half into 2x is x plus half into 1 is 1 by 2. So, in the interval 0 less than or less than 1, f of x is x plus, f of x is x plus half. You have f of x is 2 into half is half x plus 1 into half is half, 1 by 2. Similarly, third part, third case, minus 1 less, 1 less than or equal to x less than infinity. The third stage is third interval 1 less than or equal to x less than infinity. Remaining part, f of x is d by dx of f of x. Here also in this case, d by dx of f of x is 1 given. F of x is 1 in this interval. So derivative of a constant with respect to x is 0. Therefore, f of x is 0 in the interval minus infinity to 1 to infinity. So from this, you can collect all these things into this form. In the combined form, you will get the probability density function. Okay? So, our first subdivision, the probability density function. Probability density function f of small f of x equal to first half interval minus infinity to 0, small f of x is 0. So it is 0 from minus infinity less than x less than 0. Minus infinity less than x less than 0. So first part, in the interval minus infinity to 0, function is 0. On differentiating 0, you will get 0 only. Okay. And in the second part, in the interval 0 to 1, small f of x is x plus half. Therefore, x plus half, x plus 1 by 2 from the value of x is 0 less than or equal to x less than 1. And in the third interval minus 1 to infinity, the function small f of x is 0 from 1 less than or equal to x less than infinity. So this is our distribution function. First subdivision, distribution function, this is our distribution function given. From this I have derived density function by differentiating each and every term. Given interval, we can differentiate this interval. The derivative of x is 0. Derivative of half into x square plus x is x plus half in the interval 0 to 1, and in the interval 1 to infinity, derivative of 1 is 0. Therefore, this is the probability density function we are deriving from the distribution function. Okay, 1 minute. And also second subdivision in the question, they are asking you to find out the probability of 0.3 less than or equal to x less than 0.6. That's our problem. Our second subdivision is see the second question in the problem, they are asking you to find out probability of 0.3 less than or equal to x less than or equal to 0.6. See, this is nothing but capital F of 0.6 minus capital F of 0.3. This is the definition. Probability of A less than or equal to B is probability of B minus probability F of B minus F of A. You know the formula. So probability of 0.3 less than or equal to x less than or equal to 0.6 is probability of A less than or equal to x less than or equal to B means F of B minus F of A is our property. Therefore, F of 0.6, capital F of 0.6 is, you substitute capital F of 0.6 in the F of x. 0.6 lies in the interval 0 to 1. 0.6 value lies in the interval 0 to 1. Therefore, we have to substitute F of 0.6 is in this value 1 by 2 into x square is 0.6 square plus x is 0.6 minus next f of 0.3, capital F of 0.3 is again 0.3 is also in the interval 0 to 1. Therefore, again this is the value f of 0.3 is 1 by 2 into 0.3 square plus 0.3. Okay, you consider this is equal to 1 by 2 into 0.6 square is 0.36 plus 0.6. You can take the entire of common term. You can take these 1 by 2 as a common single term, that is minus of 0.3 square is 0.9. Minus into plus minus 0.3. So this is 0.6 square is 0.36 plus 0.3 minus 0.3 square is 0.09. Sorry, not 0.9, 0.09. So this is right here. This is 1 by 2 into 0.6 whole square is 0.36. 0.6 into 0.6, 0.36 plus 0.6 minus 1 by 2 into 0.03 square is 0.09 plus 0.3. So 0.3 into 0.3 is 0.09. So this is again equal to 1 by 2 into 0.36 plus 0.6 is 0.96 minus 1 by 2 into 0.36 plus 0.6 is 60, that is 0.96. Similarly here 0.09 plus 0.3, that is 0.39. You can now take that common as 1 by 2, 0.96 minus 0.39. You will get 1 by 2 into 16 minus 7 and 8 minus 3, 5. 0.57. .57 0.57 divided by 2, that is 0.285. 0.285. So probability of 0 less than 0.3 less than or equal to x less than or equal to 0.6 is 0.285. That is our required answer for the second subdivision in the problem. So that's all about the problem. We will continue the remaining topic in the next video. Thank you.